That's not what's supposed to show up. All right. There we go. So what I'm going to talk about today is an introduction to WebGL and GLSL. Basically, how do you get the GPU to draw stuff in a canvas element? So let's start out like here. How do we do this? Going over here. All right. The basic pipeline of how shaders work is we have to write shader sources in GLSL, include those shader sources into a program, compile it, link it, and then tell the GPU to run it. So luckily, the browser has basically an entire GLSL compiler pipeline built in for us. So this is, if you took CS classes and wrote C and compiled it on the command line, we're basically doing that in JavaScript, which is kind of silly, but also awesome. So, well, if my computer will do stuff now. All right, cool. I'm going to open a code pin here. I don't know if this is the right pin or not. And we're going to look at a basic. Cool. Yeah, my computer decided to not work. Anyway, okay, so with WebGL, there's two kinds of shaders that you're going to use. The first one is called a Vertex Shader, and the second is a Fragment Shader, or a Pixel Shader, but that's not what we call it in OpenGL. Pixel Shaders and Fragment Shaders are the same thing. They act on the pixels or fragments that are generated from the Vertex Shader. So what that means is, let's see if I can actually come in here, finally. All right, let's go down here, and we're going to look at this. So if we're going to draw anything to the screen in WebGL, we have to create a canvas element, we have to set it up to use WebGL, and we have to tell it what to draw, right? So this is probably too small. Let me zoom in here. All right, so we have a canvas element, as you can see here. We're going to get it by ID, tell it that we're going to get the context from it. Instead of 2D context, we want a WebGL context. Then we're going to tell it to make the viewport width and height the same as the canvas width and height, so that when it draws the same size images, because that's probably a good idea. And then we're going to tell it to what color to clear the canvas with. And you can see here, it's 4 values, so it's RGBA. So we have a slight value in the green, so you can see here this box is, well, you probably can't see it up there. It's slightly green, but here, we'll just change it real quick to make it green, right? Because we want a green background every time we clear the canvas. Cool, right? So it makes a green box. This is a lot of code to make a green box. So what we're doing at the bottom here, actually, we don't need any of this, so. Let me delete all the code that's in here. That's nonsense. All right, cool. So you can see here we have a run loop where we're requesting an animation frame. If you don't know what request animation frame does, that basically is a built-in browser interval that will run at the fastest rate it can, up to 60 hertz. Or actually, I think it depends on the refresh rate of your monitor, but in general, it's 60 hertz. So all we're doing here is we tell it clear color, this is the color to clear it with, and then we tell it to clear in the loop, and then keep doing it over and over and over. Of course, this is kind of inefficient because my code isn't actually doing anything except for drawing a green box over and over and over again. Okay, so let's go back in here and talk about the rest of this. So if we want to actually build a shader and make it render something, we have to have shader sources. So let's go open my other pins here. And all these pins are in the slides, so it should be pretty easy for you guys to click on that and follow it. Or get the slides and then come in here and look at these pins and see what they're doing. Okay, so in here we're drawing a triangle that's yellow. So cool. And what we're doing is we have these 2 strings that are the shader sources. as you can see, vSource and fSource. Then we tell it to create a program with those. We tell OpenGL to use it, and then we bind some vertices. And I'll explain that in just a moment. So now that you've seen that, we'll talk about what the variable stuff is in GLSL, the language a little bit, and what we're actually doing. And I don't want to take your survey, Google. Okay, so it's C-like, which means it's basically similar to JavaScript, but different enough to make you mess up all the time. And then we have these variable qualifiers. So like in C or C++, we have int, float, etc. But these also are added on to qualify what kind of variables they are. So we have const, attribute, uniform, and varying. And so what these do is const means it doesn't change ever. Attribute means in the Vertex shader, this is data that's passed in that may be different every time the shader's called. A uniform is kind of the same, but you can use it in both the Vertex shader and the Fragment shader. And then a varying is a variable type that is used to take data from the Vertex shader and pass it through to the Fragment shader. So an example of a varying is if you have like a box, you can calculate what direction the faces are facing, pass that to the pixel shader so you know if there's a light over here, how to calculate the direction of the light versus the direction of the faces and apply lighting. And so that's a very common use of varyings for passing data that's calculated in the Vertex shader to the Fragment shader. So here's the basic types. We have int, float, vec2, vec3, vec4, and then mat2, mat3, and mat4. Those are the most commonly used ones. Vec2, vec3, vec4 is just basically it's an array of floats. And then a matrix, or mat2, 3, 4 is an array of floats, right? The other operators that we use that are very commonly used in shaders are this operator called Swizzle, which basically lets you access the elements in a vector by the name by putting both the variable names after the dot. So if you want to extract the first two variables from a vector that has 3 elements, you can say v.xy. Or if you want to extract the first 3 out of a 4-element vector that's in a matrix, we can say matrix1.xyz, and it will only pull the first 3 elements out of that. So that's really useful because you're doing that a whole bunch in GLSL. Okay, we already talked about the 2 kinds of shaders. Okay, so here's a basic example of a Vertex shader. We're going to pretend that the projection and model view matrix get passed in for us by whatever software we're using. And so what we're doing is we have a vec3 position, which means that per vertex, we're getting the position of the vertex passed in. We're taking that, multiplying it by some matrices so that it shows up on the screen in the correct place. So that's cool, right? And in a moment, I'll show you how we're doing drawing the triangle with this. And then finally, we have fragment shaders, which you do have to put this precision medium p float, and that just means like when you run this, use floats that are pretty precise, because OpenGL ES doesn't specify which format to use by default. And this uses slightly less memory. If you're doing graphics programming, this is fine. If you're doing other stuff, you can use higher precision numbers. And you can see here, there's this built-in thing called GL color. That is the output color per pixel on the screen in your viewport. So here we're just turning them all red. So now that you've gotten a fire hose of nonsense there, let's go look at an example. So how did we draw this triangle? So what we're doing here is we have 2 shaders. And you can see here we have medium precision float, attribute 3, vec3 pause, GL position vec4. So what this does is the vertex position is assigned by this GL position built-in variable. And we say whatever position gets passed in, put it at that position. And then in the fragment shader here, we're just saying make every pixel that's part of the vertices that we got past yellow. So that's why you can see that the fragment shader is only going to affect the pixels that were given to it by the vertex shader, or the fragments, in other words. So down here, you can see we're creating a program, we're using it, and we're binding vertices. So back in my slides, I have a better example of how that's actually happening. To include shaders in JavaScript, you can either make them a string, which with ES6 is really nice because you can use template strings and they're multi-line, so that's really nice. Or you can include them with a script like this, and then use your document selector to just pull the data out of the script and pass it into a string. So this is how we actually compile and link a shader. We have GL here is the WebGL context that we got from the canvas. So we're going to tell it to create a shader of the type Vertex Shader, get the shader source called Vertex Shader source, and then compile it. Do the same thing with the Fragment Shader, and then finally down here at the bottom, we're creating a program, which basically means when we have these two compiled object files, we're going to link them together and make it an executable. So what we do is we make a program, we attach both the vertex and fragment shaders, and then we call link. And that finally will give us back a program that we can tell the GPU to run. I know there's a lot, but at the end there's actually a library I'll show you that does almost all of this for you. This is just kind of a lower level intro to like how things like Pixie and Phaser and Mapbox actually do the drawing that they're doing. So finally back to how do we draw vertices? So this is a triangle that I was drawing, and in OpenGL the screen space is from -1 to 1, right? There's no actual resolution that it gives you because it's in UV coordinates, which is the texture space. Yeah, goes from -1 to 1. That's all you really need to worry about. So you can see here, -1, -1, 0 is the bottom left vertice in the triangle, bottom right, top middle. Then we have to create this thing called a buffer. And the reason we do this is because this buffer is kind of a holder that tells the GPU to assign memory that we're going to put stuff into. Then we have to tell it what kind of buffer it is and what kind of variables it's going to hold, because OpenGL is written all in C, which means it doesn't do anything magically for you like JavaScript does. So it's interesting. So down below where I have these vertices assigned, you see we're saying GL buffer data is an array buffer. We're going to make a new typed array, which in JavaScript actually has typed arrays. So we make a new float32 array, which is just 32-bit floats. We pass the vertices in there. And then there's this last thing called GL static draw, which is basically telling the GPU a hint about the most common usage for this array that you're giving it. There's a couple different ones. You can read it in the documentation. Finally, we're doing this last thing, which is GL get attrib location. So what that does is when your executable is given to the GPU, it has variables in it. But how do you access those variables to assign values to them from JavaScript? Well, you can get attribute locations, uniform locations. Oh, that's it, right? So here we're saying, please give me the memory location of the position variable in the shader and assign my vertex attribute buffer's pointer to that memory location. Or it's saying, hey, assign this value to the variable in the shader. So we have vertex attribute position here, which is our position buffer that we created. Or position is the location that we're assigning this vector to. The second number there, 3, is telling the thing, this is an array of vectors, and that's how many elements are in each vector, because it doesn't know. Okay. And then finally, it's a float, and then the last 3 ones you don't have to worry about. Then we enable the vertex attrib array, which means turn it on and use it. So let's go back to our triangle example here, and we can see that I'm doing the same thing, binding the vertices, we're getting the position, assigning the vertex buffer. Here's the vertices that we're passing in. We're creating a buffer. We're enabling it. And then finally down here at the bottom, we're telling it to draw arrays and draw the triangles that we gave it. And because there's only one triangle, it's just drawing the indexes, the vertices from 0 to 3. So now we get a triangle. And this might seem overly complicated, but this is what all these fancy things are doing in the background. Plus, it draws triangles really, really fast. Okay, so let's go on a little bit, and we'll talk about some more shader stuff. So apparently I did that already. So the next thing we might want to do is be able to pass variables into the shader from JavaScript. So how do we do that? Well, I have a small version of Shader Toy, basically Shader Toy that I've made. And how do we pass data between shaders with the varyings and all that stuff? So let's go look at this guy right here. So we have this cool color changing square now. Whoa, look at that, right? That's amazing. So how are we doing that? We have in our Fragment Shader source here a thing called uniform vec3 color. So what we do is we tell the WebGL context to get the uniform location named color out of our program and then set a value to it. And then in our loop, we make up some numbers based on some math, and we assign it to this uniform 3-element vector that contains floats with this location. So we assign those values back to it, and then inside of the shader, every time the shader's running, it will use the new values that we passed in. So that's pretty cool. We can take and pass data from JavaScript into the shader. I have about 1 minute left. So the last thing I have is I'll show you how to, all right, how to do a varying. So in here we have a thing called varying vec2u vpos in the Fragment Shader and in the Vertex Shader. And all that does is we take the XY position of the vertex and pass it to the Fragment Shader and tell it to assign colors based on that. So we get cool multicolored 3D triangle kind of thing. And I guess that's all the time I have. So I hope that was interesting. And my slides will be up. And all of those things are on CodePen. So if you guys want to look at any of that, cool. And hit me up on Twitter or something. Oh, I didn't show any of that. I'm bad at this game. Anyway, yeah, just hit me up if you have questions or anything. I'll be happy to help you.